Goodness. I don't know. All right. Here we go. So today, lesson 4, we're talking about functions again, but we're talking about specific types of functions. There's a couple types we're talking about today. The first one is discrete functions. I'm just going to tell you really quickly, they have to be whole numbers. And I'll show you what all this means in a second. This also applies if the function is only in words. There's no numbers involved. And then a continuous function is you can use, I think I don't need that E at the end, fractions and decimals. So I'm going to kind of explain this to you in a little bit, but and they're going to ask you whether it's discrete or continuous. Really, you just have to decide, are you allowed to use a fraction in that situation or not? And if you're not, then it's discrete. So the first one says the function that assigns to each whole number the cost of buying that many cans of beans in a particular grocery store. This one tells you you have to use whole numbers. Like if you're thinking about buying a can of beans at Walmart, can you go to Walmart and go up to the people and be like, listen, I want 3.25 cans of beans. Like, will you go get that for me? Would they would look at you and be like, no, just buy 4. So this is an equation, or this is an instance where you have to have only whole numbers. So this one's called discrete. Like I said, you can't just go up and buy a half a can of beans at Walmart. They're going to just stare at you weird. Number B, it says the function that assigns each time of day, Wednesday, the temperature of Sammy's fever at that time. So if we're talking about specific times of days, it's not just 1, 2, 3, 4, 5 o'clock. Like there's more time in the day than just 1 o'clock, 2 o'clock, 3 o'clock. So this one's going to be considered continuous. I know time is kind of hard to think about fractions and stuff, but if you think about it, you could have an hour and a half or like 3.5 hours, a quarter past noon. That's a time. So you can use fractions and stuff when you're talking about time. The function that assigns each real number its first digit. Real numbers can be fractions, they can be decimals, they could be whole numbers, they could be positive, they could be negative. So C is going to be continuous as well, because when you're talking about real numbers are any type of number. The function that assigns each day in the year 2015 my height at noon at that day. So we're talking about like January 1st, January 2nd, January 3rd. There's no other information you could write with that. That's going to be like discrete. Because you don't care if it's like January 1st at 12 o'clock versus I guess you do at noon, but it's the exact same time every single day. So you're not focusing on like half an hour or anything past that. So anyway, E, the function that assigns each moment. This is where it gets a little different. When you're talking about a moment in time, it could be any specific time. Like when you stop at a certain moment, it doesn't have to be a whole number. So this one's continuous. I hope that makes some sort of sense. Like if you stop time right when you need to stop time, it doesn't necessarily mean it's going to be 1 o'clock p.m. You know what I mean? It's not just going to be 1, 2, 3, 4, 5. It could be 1 o'clock, 1:31 with 30 seconds. Like it could be a specific moment in time. F says the function that assigns each color, the first letter of that color. So this one's all in words, and I wrote down at the top that if you have something that doesn't even use numbers, that's considered discrete. The function that assigns the number 23 to each and every real number between 20 and 30.6. Right there, it uses 30.6. So I know for a fact that this is going to be continuous because it doesn't matter if you use decimals or not. Oh, gosh. The function that assigns the word yes to every yes or no question. This is discrete because you're only using words. It doesn't, like, there's not really numbers involved. And if you're only using words, that's considered discrete. The function that assigns each height directly above the North Pole the temperature of the air that height right at this very moment. That's continuous because once again, we're talking about at this very moment. Okay, that's your first page. Example 2 says water flows from a faucet into a bathtub at a constant rate, 7 gallons every 2 minutes. This is the same exact problem that we did before. If you're trying to come up with an equation for this situation, like this is what we did the other day. It was on lesson 3. You always start with y divided by x. Time goes on the bottom. 2 minutes is a time, so that goes on the bottom, and you cross multiply. 2 and y point to each other, and 7 and x point to each other. So when you solve this equation, you get y equals 3.5x. They want to know, is this continuous or discrete? When you're thinking about gallons of water and time, do you always have whole numbers? Like if you got your water bill back, is it always going to be like you used a whole number gallon? No. It could be like halves, it could be decimals, anything. So this is continuous. Okay, this one's interesting. You have just been served freshly made soup that is so hot you can't eat it. You must measure the temperature of the soup. It's 210 degrees Fahrenheit. 212 degrees Fahrenheit is boiling. There's no way you could safely eat it. Then it says 1 minute after you record the temperature again and it's at 203 degrees Fahrenheit. So what we want to do is come up with a rule for this equation. You start with a y equals, and then you want to start with the temperature that it starts at. It started at 210 degrees Fahrenheit. After a minute, it had dropped to 203 degrees. So how much did it actually lose in a minute? Yeah, and that's going to be the other part of your equation. Every minute, it should lower 7 degrees. All it asks you to do is write an equation, so that's what we did. This is the number this is your starting like temperature, and then it subtracts 7 degrees every minute. This one, they're not really even asking us to do anything, but this is an example of a discrete function. If you look right here, player number 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's like a roster of players. When you're writing down player numbers, you're never going to write down like player 3.75. Like that's just not going to happen. They're never going to do it. When you're talking about people, it's a whole number. That's why this one is discrete. And this one's just specifically talking about the height of a basketball team, maybe. I don't know. It's discrete because the player numbers have to be whole numbers. Okay. So this table represents buses at a certain school, and some person makes this table saying like, okay, if you have one bus, you have to have 35 people on it. If you have 2 buses, you have to have 70 people on it. 3, 105, and 4, 140. How many of you guys ride a bus? Do you have the same number of people on your bus every single day? No. This guy's saying like one bus, it's gonna have 35 people on it. And Alicia says, like, your math is right. Like, a bus could hold 35 people on it, but it doesn't have to have 35 people on it. Like, you could have one person who's going to school, and you still have to have one bus. So this guy is, he made the wrong table for this because he left out a ton of information. Just because a bus can hold 35 people doesn't mean it's going to hold 35 people, okay? So Alicia is right. Explain why it's not a linear function. There's just missing information. and there's no constant. I can't write with this one. Here we go. Missing info, and there's no constant. My mouse is messing up. There we go. All right, and then it asks you down below, is this discrete or not discrete? Well, when you're talking about students and buses, could you have like 30.25 students on a bus? Don't even answer that, actually, because we've had some interesting conversations today. No, you can't have half of people. You can't have half buses. So the answer is that this is discrete. We're not even going to argue that. People like to do that, but we're not going to do that. Yeah, right there, you should have said discrete. You have to have whole numbers for both x and y in this case. Number 2, a linear function has the table of values below. It gives the cost of purchasing a certain number of movie tickets. So you're going to the movies. This is the table that goes with that. You want to come up with an equation for it. So you start with y divided by x. You have all these different pairs. You have 3 and 2775. You don't have to do that. You just have to pick one of them. It tells you that this is the total cost, or the y. So that's going to go on the top of my equation. And the x goes on the bottom of my equation, which is 3. We're just wanting to come up with an equation for this. So we're going to cross multiply what points to y. So 3 and y are now together. What points to x? Yeah, 27, 75, x. Last step, divide by 3, and that's going to get you your equation. Y equals, take 2775 divided by 3. Yeah, that just means one ticket costs $9.25. Want to know, is the function discrete? Okay, let's look at our x values. Okay, if you go to the movie theater and you go up to the place where you're like paying for everything, can you be like, listen, I want one whole ticket to this movie, and then I'm gonna just get a half ticket over here. I'll stop by there for half the movie, and then I'm gonna go home. Can you do that? No, you can't. You have to buy whole tickets. So this is discrete because you have to buy whole tickets. They're not going to let you buy 3.5 tickets. It's just weird. This box is in the way of this problem, but it says what number does the function 4 assign? So you're going to say y equals 9.25 times 4. And then it asks you, what does that mean? So what is 9.25 times 4? So that just means 4 tickets cost $37. So when it asks what it means, that's what it's talking about. Explain what you just did. 4 tickets, $37. All right, the last couple of questions is this one. It says a function produces the following table of values. Input banana, the output was B. The input cat, the output was C. I don't know what that word is, so we're going to skip it. Input is oops, the output is O. The input is slushy, the output is S. It says make a guess to the rule of the function below. Each input is a word from the English language, and you're going to say each output is what? Yeah, each output, and hopefully you noticed, is the first letter of that word. Is this function discrete? We are only working with words here, and if that's the case, then it's always going to be discrete. If there's no numbers involved at all, it's discrete. I'm going to pass out the homework, and I'm actually just going to do it with you really quick. It doesn't take very long. Okay, moving on to the homework. So it's the same type of thing. My homework up here looks a lot like I spread yours out so much farther so that you could have some room to write. But the first one says the cost of purchasing gas is shown below. 5.4 gallons cost $19.71. 6 gallons cost $20.90. Blah, blah, blah. We're going to answer these questions. I'm just going to write them. You guys have room to do all this on your paper. A says write an equation that describes y as a linear function of x. So it wants you to write an equation. You start with y divided by x. All you have to do is pick one pair of these numbers. It doesn't matter which one. I'm choosing this one right here, the first one. I'm going to take 1971 and put that on the top. And then divide it by 5.4 on the bottom. Cross multiply. So I draw my diagonal line from y. It points to 5.4, so those two are now together. Draw my diagonal line from x. Oh, on the homework that I just passed out. The first one. It says A. We are on A. I don't understand how you don't understand. It doesn't look like mine. I said that. I gave you extra room to write. Divide by 5.4. So we all have calculators in here. Take 1971 divided by 5.4. Yeah, that just means 1 gallon of gas costs $3.65. That's expensive compared to our prices for gas now. They are going up, but still cheaper than that. Are there any restrictions on what kind of numbers you can plug in for X or for Y? We're talking about gallons of gas and money. What kind of numbers can you not use? No negatives. That's typically going to be the restriction that you'll have when you're looking at these types of problems. Gosh, why won't this work? C says, is this function discrete? Yes or no? We look up here, your number of gallons. You could have any type of number. You could have a decimal, you could have a fraction, you could have a whole number. So this is going to be continuous. Like when, I don't know if any of you guys have ever filled up a car with gas, but like when you plug in the gas thing and it stops, it's probably not going to be at a whole number. It's probably going to be at like, I don't know, mine's usually at like 13 point something gallons. And then the last one, what number does the function assign to 20? So we're going to take the equation that we had, y equals 3.65x, but instead of writing x, we're going to take it times 20. So 20 gallons of gas cost how much money? You just have to do that little multiplication problem. How much? $73. My mouse is messing up really bad. All right, then the back, same exact thing. We're doing Another problem that's very similar to this, mine does not look like yours. I gave you extra room to write, so keep that in mind. A says write an equation. So we're going to take y divided by x, and we'll use those first two numbers, 144 and 3. Or not 144, 141 and 3. Diagonally, the 3 and the y point to each other, and the 141 and the x point to each other. So all you have to do to get your equation is divide by 3. In this case, we're talking about driving, hours driving, and how long it takes. So what did you get? 40? What'd you say? 47. That's the answer to part A on the back. Part B, my voice is like going out. B. Same thing. Any restrictions, it's the same answer. You can't have negatives. I'm not used to talking this much all day, every day. C. I mean, I do, but a lot of times, like, the lesson's not this long. And I just sat for a whole weekend, so. Is the function discrete? Look at your x values. Can you drive for an hour and a half? So it can be continuous. Just because they didn't put any decimals or fractions in there doesn't mean that it can't be. So it's continuous because you are allowed to drive half hours, quarter hours, any of that. Last two questions. What number does it assign to 8? So you take y equals, and you take 47 times 8. That just means in 8 hours, how far have you driven? Yeah, so 376 miles in 8 hours. Last one, it tells you how many miles you drove, so you're not plugging that in for x, you're plugging that in for y. And you'll divide by 47. This tells you how many hours you can drive in 500 miles. 10.6 miles in 500, not miles, hours for 500 miles. All right, that's our lesson. That's all we're doing today. So you can put that away. Make sure you don't lose your bell work. What do you need, Ethan?